Okay, guys, so welcome everyone. We are recording to a demo session on cloud performance engineering and DevOps and SRE, site reliability engineering. Okay, so in this demo, what we're gonna do, we're gonna go over the course that we are coming up with. The Isha Training Solutions is coming up with, and we'll go over the course. And you can ask, you can understand the course syllabus and what you're expecting, right? We'll just go over the session on the regarding the course curriculum and what's the thought process of coming up with the course and how it's going to benefit all of you. Before I get started, I would like you to just confirm. Most of my folks who join my webinar or demo session are mostly from the performance engineering testing background, and they are looking to upskill themselves and understand the SRE and the cloud performance engineering scope. So, is the same group joined here as well? Just you can just put it in the chat. Is most of the folks are from performance testing engineering background, aspirants? Uh, would that be a right assumption? Okay, Akash says yes. Okay, Satish, yes. Okay, looks like yes. Perfect. Good, guys. So we are on the same page. Okay. So before I get started, let me introduce myself. Okay. So my name is Roshan. Guys, I have been in IT in industry from last 16 years. I started my career with Java development, okay, and then I moved into performance engineering, where the crux of performance, the Java performance engineering, the Java coding lies, optimizing the code, right? So that was the one of the roles that I have taken up for quite some time, 6 years, 7 years. But nowadays I'm mostly into this DevOps and SRE practices. I am the principal SRE with one of the reputed retail giants you can imagine. Okay, so handling trillions, like millions of users at scale, taking care of production reliability. Okay, so that's the difference between the performance engineers who benchmark the application and the SRE. In SRE, basically looks into from the production point of view, making sure production is highly available, reliable, and secure, and those aspects will come to that. Okay, then I have spent quite a long period in the automation part, used various automation tools, like I have been used Selenium for the UI automation, then Python scripting, Shell scripting, Terraform, Ansible, like a lot of tools, right? On the cloud credentials, I am a multi-cloud solution architect certified, done certification in all the three major cloud service providers. I've been lucky enough to work in all the three, AWS, Azure, and GCP. Okay, so that's about me, guys. As part of my hobby. Sorry, a bit glitch. As part of my hobby, I like to share my knowledge and travel. Okay, so that's what I do. On my teaching experience, I have been teaching from last 6 years. I'm with Isha from last 3 years. I teach with other institutes as well, Intellipath, Eureka, Simply Learn. All right. So yeah, I engage them there as well. Okay. So that's a background about me, everyone. Um, okay. So before I get started, okay, I always start with a question. Okay, I always start with a question, and I ask this question, and then we'll go over the something called software development and deployment evolution, how the software has been developed and deployed over the years, and then we'll look into the course syllabus, what it is in the course, what you should expect from the course, and what you will learn by the end of the course, and then follow by the Q&A. So that's how the session is planned. Okay, so let me start with the question, everyone. Okay. So you see there are four words that I have used here in the slide: DevOps, microservices, containers, and cloud. Right. So, and the question is, do you think the performance engineers are expected to know all of this as per the current market trend, as the industry is headed, where the industry is headed, and the way you may be looking into the interviews, right? Or right. So, do you think, guys? uh, performance engineers or aspirants of SRE, do you think these things are important and must to have? Just your perspective, everyone. What do you guys think? Yes, no, no idea. Anything could be fine. Kishore says yes. Raman says yes. Okay. Guys, trust me, if you have been taking up interviews, you would know this what I'm talking about. Okay. This is gonna be the thing. Okay. Will be asked. I'll tell you why. There's a reason for it. Okay. And I'll show you the next slide and you will understand where these things land. Okay. If you look at the software development and deployment, both over the years, right, you will understand where these four things fit in. Okay, let me, here you go, the next slide. Okay, if you look at this, so this is where it fits in. If you look at the how the software has been developed and deployed over the years, so you know that when around 1980s, on the development process, we all started with waterfall, right? And then we moved into agile. We know the problem with waterfall. uh, we all know, right? I hope, I'm assuming we all know the problem with waterfall, that we used to develop everything first and then we started to test. And it was so difficult for us to go back to make some fundamental architectural changes. That was the thing with the waterfall. We learned from our mistakes and we moved to agile, where we did great. We are still agile. It's not like agile we are not using. We are still using agile, where we took the software development into phases. We developed one phase, and we did all the SDLC. We did testing, all sorts of testing, functional, performance, security, right, UAT. And then we took the feedback from the customer. We incorporated the feedback in the next phase, and our end product that we got at the end was very much in line with the customer expectation, was able to scale, and we were able to remediate or were able to mitigate the any architectural flaws quite early. It was not left for the end as case of the waterfall, right? And now we are in DevOps world, right? And this was one of the things that I put there, because that's how the software has been developed, because we want to solve the problem of agile in DevOps. That's why this DevOps is. Whatever the problem, the shortcomings of agile were there, we are trying to solve the problems of agile in DevOps through automation. We'll understand in detail. Okay, once we understand the DevOps, what it is. See, understand one thing. I'll just make it brief. When the code is ready, when the developer writes the code, when the code is ready, what is the end goal? End goal is to deploy the code to the production. That's the end goal. But we do a lot of validations. We build the code, we get some artifact jar file, we test, we do functional testing, we do performance testing, we do security testing, and a lot of time gets spent, I would say, in this process to back and forth messaging and a lot of things. So why not automate it so that the time release velocity of the product when the code is ready minimizes and we're able to deploy the code in the production at the earliest. So that's the thought process. So that's the thought process of using the DevOps. We are using agile here. In DevOps also we use agile, but we automate the process so the time to release the product reduces, the release velocity increases. That's what we do in DevOps, right? So that's on the development process. We have made a tremendous progress on the architecture as well. Earlier, we were dealing with monolithic applications, but nowadays, if you look at, we are dealing with microservices architecture. It's all microservices. Our monolithic applications are being converted to microservices, and the newer developments that is happening in the case of all happening in the microservices. I'll tell you one example of microservices. All the recent applications that you see, the Swiggy, the Uber, all those recent applications are being developed in microservices. The best part of microservices is that the one core functionality does not impact the core functionality of the other, right? We interact through the REST API calls. So let's say consider this application, Make My Trip, right? You log into the Make My Trip, you book a flight ticket, to Indigo, Air India, Air Asia, so many flight carriers, you book the ticket, right? How it is possible? Do you think the Make My Trip has the database access of all Indigo, Air Asia? Like, do all the do you think that we have the database access? No, it's all through the REST API, because it's all microservices based architecture, right? So that's how the communication is happening, right? So if I tell you, let's say the Swiggy or Uber application, if a notification, there is a functionality called notification, which is at the top right corner. Whenever you book a cab or order your food, the notification, you get a notification that you've ordered your food or the cab has been booked, right? You get a notification. If I tell you, if a notification is not working, you will not be able to book your cab. You will not buy this. You see, it's not a good application at all. And that was the case with monolithic applications back then. It was so interdependent, tightly coupled. We were calling the functions from one module to other module. It was so tightly coupled in the case of monolithic applications, and that was the case. One functionality breakdown can bring the entire application down. But that's not the case with microservices. If Indigo server is down, it's not going to block Make My Trip making calls to Air Asia or Indian Airlines, right? All are microservice based architecture, and we're able to book flights through API calls. It's not like the Make My Trip has all the database access. It's all microservices world that we're dealing with, right? And that's what brings us to the next topic. Where should we deploy the microservices? So we are breaking down the application from monolithic to microservices. Earlier, we used to use, back then, the physical servers. When there was no virtualization in place, no virtualization, right? We used to deploy everything on the physical server. Then virtualization came and we created VMs, multiple VMs we could create. And we had this 3-tier, N-tier application. We used to deploy each one application on each server, right? Let's say I'm deploying app server. Let's say I'm using one VM to deploy my app server, one VM to deploy my web server, one VM to deploy my database server. Right? This was the case. But again, over the year, it was found that we are not able to utilize the resources, the CPU and the memory of these guys. We are wasting resources. So what was the next move? Next move is to containerize it. So in one VM itself, can I run multi-tier application? In one VM itself, can I create 3 containers where one container is my web server, another container is my app server, another container could be my database server? Can that happen? That in one VM, can we do that? Yes, it is possible through containerization. When we install container engine like Docker, we can do that. And when we split this, the microservices are the best candidates to be deployed on the containers. We are splitting the bigger applications to smaller applications, right? And we can deploy separately. One microservices to one container, another microservice to another container, right? And that's why we talk about Docker, deploying microservices. And when we have got a lot of containers, we need to orchestrate them. We need to auto scale in production. When the load increases, auto load balancing, auto self-healing, auto scaling, orchestrate them through Kubernetes, right? So this entire thing, right, from a technology perspective, I'm not talking from a performance at all right now. I'm talking from a just technology perspective, where we are headed, right? And we need to understand, because when the technology is progressing, our performance engineering skill set needs to get upskilled as per the current, how the software has been developed and deployed. So we need to have the thought process of a skill set upskill with that, right? So that's how the situation is. You guys able to follow me what I'm talking about? Any questions till this point of time? Anything you want me to repeat, or you could not follow? Are we good? Please give me a thumbs up, guys. Yes, no. Are we following things, guys?
Yes, yes, sir.
Okay,
So far
perfect.
it's good.
Okay, good. Others all good, right? Perfect. So now, next thing, right? Now, when it comes to where should we deploy? So first of all, see, to create VMs also, to create physical server, we need, either you need an on-premise system, or you need cloud, right? We need this. So earlier, back in 1980s, when you have a business idea like Amazon.com, you had no other option but to set up your own data center. Jeff Bezos did that. He set up his own data center to deploy Amazon.com website, but he did great. He, while doing that, he got this idea of Amazon Web Services, AWS. He thought the whatever he was doing for his data center, the same data hardware software can be leveraged by others also. And that's what we are in the world of cloud. Now we don't have to invest so much. If you have a business idea, you can just get some servers in the cloud, deploy your application in just within minutes, within hours. It's not a big headache or big thing to set up your data center. You have to set up your own data center now if you have a business idea, if you have something. Right? In the cloud, I can just go to cloud, get some servers, deploy my application, I can up and be running in just few minutes, few hours. That's how it is if you have the code ready. Right? So we are in the phase of cloud. So earlier, if people those who are in the industry from quite some time, they will understand earlier we all used to work on the data center. The big companies used to have this data center. We used to connect to, see, for us does not matter, right? Either you work on the data center on premise, it all depends. See, what is the difference on premise and the cloud? The data center which you own is your on premise, which you don't own. Like AWS has set up a data center, but you don't own it, but you use it. You pay them rent for the hardware or the servers or the storage services. That's the cloud. So we are in the phase of cloud now. So we are in this. So that's why I talked about these four things, because irrespective of which technology you are, you could be in as a functional tester, you could be a support engineer, you could be anyone in the industry. Everyone has to know this, because that's how the software development is and deployment is happening, right? And since development is happening on the microservices, we need to know how do we deploy that. What are the performance challenges? What are the challenges which can happen in production? We need to understand that so that we can look into its performance scalability, its reliability, right? We can look into those things. So that's why I highlighted these four things. It's very important, right? So that's how it is. The world is right now. And if you go to any interview, they will ask you questions on Docker Kubernetes, whether you understand microservices or not, whether you understand containers or not. What is the benefit of containers over VMs? Kubernetes, tell me about the auto scaling Kubernetes, tell me about the services, tell me about the ingress controller. It will be there. Tell me about the cloud, what cloud you know. Then they will talk about, okay, you know Jmeter, okay, fine, you know performance engineering, not define. Tell me about how do you tune this, how do you tune that. They will ask those questions, but this is gonna be the base, right? And that's where I'm here with this course, so that whatever you are lacking as per the current market trend or where we are going, you need to upskill yourself. That's why this course is designed for, right? One of the very popular courses with Isha, right? And a lot of, I say because I'm taking this course from last 2 years and I have been seeing the interest growing, right? So I can say that from experience from last 2 years, right? Because we're able to understand that's the challenge, because I have been in your shoes, right? If a company is using cloud, if I don't know anything about cloud, I would not be able to performance test, right? If I just know Jmeter or take the heap dump, thread dump, I would not be able to understand what is the cloud architecture. Because as a performance engineer, you need to first understand the architecture, architectural components. Then you can drill down to understand would the bottleneck could be because of that component, or how that component is playing a role. Those things, right? So that's about this slide, guys. So I'm going to directly deep dive into the course syllabus now. What we are planning as part of this course, right? I'm going to take you to the website, okay? Let me talk about that first. So this entire course, as I told you, the four topics: the cloud, the microservices, the containers, the data DevOps, right? And apart from that, performance engineering, Java performance engineering, monitoring. So the entire course is based on that, okay? So if you look at the cloud computing, we are talking about AWS, Okay, we talk a lot about AWS to a level of solution architect in this course. I know on my experience that people are not comfortable in Linux as they are with Windows. Most of them, I'm saying, not all of you, but most of us are not comfortable in Linux as we are comfortable with Windows. That's how it is. So for them, there's a special section of the Linux command line where I talk about the basics of Linux. How do you navigate directories? Like, I just want you to be comfortable with Linux as you are with Windows. At the end, it's just an operating system. Why this big thing, Linux, right? It should not be big thing. Okay, just an operating system. Okay, I will operate it. I will issue some commands. It's not GUI. Fine. I will issue some command, get the work done. So we'll talk about the Linux command line. On the architecture part, we need to understand what is monolithic, what is microservices, right? We need to understand that part. And where do we deploy this? How do we deploy this? How do we create containers? What is Docker? What is the Docker lifecycle? How do we create containers? How do we deploy application? Then only we can understand the if you need to give more memory or code to a particular container, how can you give that? Because containers are like your processes of an operating system. How right now this Google slide I have opened, right? And I'm using a Windows laptop. So this Google slide is consuming some Chrome is using some resource of my operating system. Same way containers are, but to a different level because they gives you segregation also, right? We'll talk about containers, just like a process for the operating system. We'll understand about Docker containers, how do we deploy Docker container lifecycle. We'll talk about Kubernetes. That's the most important thing. Orchestration, because Kubernetes gives you orchestration. Or when I say orchestration, automated deployment. How do you make sure when I deploy one application, I don't get a downtime in production? Because see, understand, for a user, what matters? At the end, what matters? Just think this, relax and think through. If Amazon.com is there, right, website, what matters to us? First of all, I don't want Amazon.com. I'm expecting Amazon.com not to go down, not to have downtime at all. First thing. Performance wise should be like a charm, performs like a charm. If I'm clicking on something, should be just could be flowing. I don't want any lag or page is rendering and taking time. I don't want to do that. Don't want that. Should be secure. I don't want the user data to get hacked, right? I'm putting a lot of credit card details. I don't want that to happen. Security. See, everywhere these are the three things: high availability, reliability, no downtime, security, performance. That's what I want. And Kubernetes is a pioneer in that. Kubernetes offers you self-healing feature. If a container is running in production, let's say, I'm giving you one example. Let's say a container is running in production, let's say in Kubernetes cluster. And let's say that container happens to be a Java process, let's say, and out of memory is happening. Some problem with one of the objects, a lot of time, some heap getting filled because of this particular object, some method call, and out of memory exception is happening. You know what will happen? You will never have a downtime because as soon as your container goes down or restart for a region, it goes down because of out of memory. The Kubernetes will create a new container. Self-healing process, self-healing feature. These comes under the orchestration, self-healing. The containers will self-heal. Though you have the issue, you at least you get the time to troubleshoot it. Look into take the heap dump, look into the GC log. You can take the heap dump, understand which object is causing more, where the shallow heap and retained heap is having quite a big difference. The root cause, you can drill down to the method level, understand the root cause, which particular object is taking most of the heap. And you can talk to the developer why this behavior. You can suggest them some data structure, some algorithm, or some whatever the depends on the issue. At least you get time. At least you don't give a data downtime because of Kubernetes, because it's a self-healing feature. Auto scaling. If today 100 users are accessing the application, if next 15th minute, next hour, double users came in production, the containers will auto scale. Auto scaling, self-healing, auto deployment. When you're upgrading the image from V1 to V2, You don't have a downtime because of the blue-green deployment and rolling update. You don't get a downtime. There are a lot of features in Kubernetes, and that's what is popular. Kubernetes is going to be the standard. Like now, what has happened to the cloud? Everyone is expected to know cloud. Same thing is going to happen with Kubernetes. It is already happening. Every company is using Kubernetes. Any resume you look at, it will never be without Docker, container, Kubernetes. Obviously, we need to understand performance engineering. That's the core thing, right? And DevOps. How performance engineering fits in DevOps and other automation things. I have not added it here. I should have added the things here. We are also, let me add it here, this slide here. We have also added what we have added. I'll tell you the eliminating toil process. I'm going to take you to a website. You'll understand what I'm adding here. Eliminating toil using Ansible and Terraform will be automation, or because automation is the key, guys. Automation, either you are a performance engineer or SRE engineer or DevOps engineer, automation is the key. We are talking about observability, monitoring part. We are using Prometheus as part of this course. Prometheus, Grafana, and ELK. We are talking about this. We are talking about SRE, right? So that's what we are talking about here in this course. Okay. So let me take you to the website. Okay, that would be better. So, which let me. Okay. So this is the course, guys. I'm gonna share this link with all of you. You guys can go over, but let me give you a walkthrough of the course. Okay. You can go over the recorded session, guys. I have been taking up. So this is the recently concluded uh, November batch. Okay. Currently, my Feb batch is going on. It's gonna complete this weekend. Okay. So yeah, you can go over the detail. Let me just walk you through. If you look at the course syllabus, we're talking about AWS in detail. I don't want to bore you if you are listening it for the first time. So this may look, what is this, right? But it is not. After we complete the course, everything would be you will be understanding whatever we have listed here. These are all the AWS things, services that I have listed here. Right? Everything is going to be hands-on and from scratch because I know my audience is trying to upskill and they are having some performance. You'd be having some performance background, performance testing, some tools, right? That's what I expect from the audience, but I don't expect you to know anything about the cloud. So I'll be taking everything from scratch. So that's the expectation. That's what I'm going to do about my audience. Linux, as I told you, again from scratch, everything that we're going to discuss. Okay, so it will be recorded videos. Okay, I'll be taking up cloud part first. I'll be starting with AWS. Okay, the first topic would be AWS, and I'll be sharing this recorded session. I want you to complete this. It's my own recorded session, guys. I don't want to waste time here because that's going to be very simple walkthrough. So you'd understand this. Okay, it's easy. Then we'll talk about the SRE part. What is SRE? What is reliability? What is it? What is fault tolerance? What is high availability? What is disaster recovery? These words, what is SLA, SLIs, SLOs, change management, incident management? What is the roles and responsibility of an SRE engineer? We'll talk about that, right? We'll talk about architecture, monolithic microservices. We'll talk about where should we deploy this on the Docker, Kubernetes in detail. Kubernetes, guys, in detail. We'll talk about Kubernetes in detail. We'll talk about DevOps. What is DevOps? How performance testing fits in DevOps? The CI/CD pipeline. How performance testers can contribute in DevOps. How can we use your own CI/CD pipeline using Jenkins? Right? We'll talk about that. Performance engineering in DevOps. Gaining resilience and reliability on AWS. Observability, as I was showing you. Observability. I'll be sharing because I know that you guys are from performance engineering background. So I'll be sharing my own recorded session of performance engineering. Okay, as part of this course. will be bundled. So performance engineering, okay, Java performance engineering, GC algorithm, heap dump, thread dump, GC log analysis, heap dump analysis, thread dump analysis. I'll be sharing all those knowledge, a lot of links, materials with you. I'll be talking about the automation part, right? And I told you the cell scripting, right? The recorded sessions, and you'll be also will be given the core Java, the recorded session, and the Python scripting, because Python scripting is also important for an SRE engineer. So you'll be getting all of this, okay, in this course, okay. Uh, there are recorded sessions as well, like Python would be the recorded session, but I'll be taking one of the sessions with you on how to. This is on the coding part, okay, but I'll be talking on the automation part. How, what the different use cases, what all you can automate using Python. So once you go over it, you will understand that what are the different use cases you can solve in the company. Once you do that, right, you'll be recognized. Okay, this guy knows Python. This has this got idea. So I'll be sharing some ideas on the Python. What all you can automate. Core Java, because since you are a Java performance engineer, you need to have basics of that. I'm assuming if you don't have, this is going to be helpful. The core Java programming knowledge. Shell scripting, I'll be sharing. These three will be the recorded sessions. Okay, only these three: shell scripting, core Java, and Python. Apart from that, everything would be live with me. Okay, that's how it is planned. The course, right? You will be getting. Let me share something. Okay, you will be getting. I'll be sharing a lot of documents with you. Okay, a lot of documents. If you look at my recent batches, February batches, you'll be getting like this all the documents. Okay, I'll be sharing a lot of documents on the cloud computing, the PPTs I'm talking about. Okay, so Amit has a question. Okay, let me answer Amit's question. Amit has asked a question. No, it's not a dumb question, Amit. Trust me, it's not a dumb question. See, DevOps is a bigger umbrella. Okay, understand? DevOps is a methodology that we have adopted so that our release velocity can be increased. Okay, that's what it is. So when you say SRE is the site reliability engineering. It's a practice. DevOps is a methodology. And SRE is a practice. Understand this. If you talk about a DevOps engineer and a SRE engineer, what is the difference? I can talk about that. But if you're just talking about the word, engineering is a practice and DevOps is a methodology. First thing. But let's say I'm assuming your question is mostly on what a DevOps engineer would do and what an SRE engineer would do. If your question is in that line, so DevOps engineer will help deploy the code to production, automate the process, and deploy the code to production. But SRE engineers are responsible to make the production highly available, reliable, stable, highly performing, secure. Anything happens to production, runtime, customer having issues, performance issues, response time. It could be any other issues, disaster recovery, high availability, right? Oh, all those things, the runtime, because the production, that's the think, guys, everyone. Think. So as a end user, as a customer, what do you expect? See, performance testing, automation testing, security testing is one part. That is kind of validation. Code is ready by the developer, and we do these validations using functional testing, performance testing, security testing. We do validations, nothing but the validations. But think from an organization point of view, what they expect. They expect, yes, Amia, I'm coming there. Okay, I have seen your question. Don't worry. I'm speaking something, right? Hold on. I've seen your question. So, what end users expect? What end users expect? End user, the customers. What customer expects? Customer expects the production to be highly available, reliable, no downtime, no performance issues. Correct? Yes or no? If I am the owner of Amazon.com, that's what I would be expecting. Yeah, there are some performance engineers who will be doing the testing, some functional tester. But what is my end goal? When I'll be happy? If an automation engineer will run a test, okay, I'll say, okay, fine, good. If a performance engineer will run a test in non-production environment, okay, good, I'll say good. But if my production is highly available, no issues, then I'll be the happiest, because that's what I'm expecting. Correct? Will that be a right statement, guys? So think from a customer perspective, and SREs plays a very important role in the production, making sure production is available, highly available, no downtime. Right, that's what it is. So okay, so coming to Amiya question, yes. Like the way we are recording, every session will be recorded, everyone. Every session will be recorded. Okay, let me share something with you, how it will be given. Okay, let me share some direct. If you look at the WhatsApp group, okay, let me just directly show you the WhatsApp group itself. If you look at the Feb batch right now, okay, so we are sharing this kind of recorded sessions, okay. So this will be recorded session, will be like this, okay. So we'll be sharing this kind of playlist with you, okay, on daily basis whenever I'm taking up the session. Look at this is the Feb batch, okay, Feb currently that's going on. So I'll be sharing, you'll be getting this playlist access, and only you will have the access, and that's what the daily wise will be taking up the session and getting uploaded, and this will, you will have the lifetime access. Okay, Amia, sounds good, everyone? Okay, so Venkat has a question. Hi Roshan, when exactly a SARI job starts? I mean, after developing application from developer, it's something like. Correct. See, okay, in production there are multiple jobs, Venkat. Okay, there are L1 engineers who would be working in the shift 24/7. They'll be looking into production. They'll be looking into the all the metrics that an SRE engineer would set, right? All the dashboards, production dashboards, right? Uh, we'll be looking into them. You will be setting alerting. See, one of the roles and the important thing of being an SRE is to set up alerts, because nobody can look into the monitor 24/7, right? So best to set up the alerts, efficient alerts, so that you get notified. If an issue comes, you get notified, and then you start looking into that. Alerts should be like that. You get some time also. Let me give you one example. Let's say CPU utilization of a component. Let's say if at 60%, I'm going to ask you a question. You guys are performance engineers. I'm going to ask you a question. If there is a workload, there is a component application which shows an exponential decrease in performance when the CPU utilization reaches 70%. There is some situation because the workload, the component, the application is core CPU core intensive. Whenever the CPU utilization reaches 70%, you start seeing performance degradation heavily. The response time going for a high, five status scores going 502s, a lot of 502s, 500 also you have started to get errors in the logs. You start to see a lot of abnormality in the application, 70%. So considering this case, guys, tell me, I'm going to ask you this question: what your alert condition should be? Is it 65%? Is it 69%? It is 70%? Or it should be 50%? If you think 65%, 70%, you are too late in the game. You don't have time to troubleshoot it. You don't have time to look into the issue, right? So your alert should be set in such a way that you get notified before the issue, before the customer starts to experience degradation. Before that, you get notification and you start looking into that so that you can resolve and do some mitigate the issue before the customer experiences it, right? And you don't set an alert for one spike. Do you set alert for one spike, guys? Let's say CPU utilization reaches 55% or 50%. Set the alert. Do you do this, or you want to wait for some time, 5 minutes, 5 spikes, then you would like to get alerted? That would be the efficient alert. What do you guys think? Obviously, one spike may give you the false alarm. It may not be right. right? We should not decide based on one spike. We should wait for at least 2 3 minutes, 2 3 spikes, then we should decide. Are we guys following things? Yes, no? Are we following things here?
Yes, Roshan.
Right. So we'll be talking about all of these guys, right? What is the importance of DR? Disaster recovery. Do you really need a DR, disaster recovery scenario, or only one cluster is good enough, right? What if the cluster goes down? You'll have a downtime. How to avoid that? So we'll talk about those scenarios, guys, in production from a SRE perspective, and very much in line with the performance. Uh, what people are expecting from nowadays from a performance engineer, right? So I'm gonna share this link with you, all of you. Okay, I'm gonna share this link with you. I call this SRE plus Cloud PE course. Okay, Cloud Performance Engineering course. So I have shared the link with you. Okay, the today was the first demonstration, and we have already started our next. It will be meeting on the weekdays, guys. The same time, 9 p.m. to 10 p.m. We'll be meeting up daily. But since I'm a working professional, there may be a situation that one day or 2 day we may not meet. So we'll be compensating that by just have one Saturday 8 a.m. to 10 a.m. time also reserved. Okay. In case if you're not able to meet 5 days or at least 4 days, we're not able to meet. So I'll be taking one extra session on the Saturday, 8 a.m. IST. Okay. So just have that in mind. Considering the working professionals, I may get into some meetings, some production issues, right? We can't help that. Production issues can come anytime, right? So yeah, that would, but we'll be following this Monday to Friday weekdays, 9 p.m. to 10 p.m. the same time what we met today, right? Right. So that's about it, guys. Okay. So we talked about the course, right, in detail. That's the course link, guys. Please go over the recorded sessions. I have some recorded sessions. You'll understand more about it. You have the course syllabus with you, and these are the feedbacks from my all my learners. Okay, all my learners. I have shared some screenshot with them. Did they put it here? Let me check it. I have asked them. Okay, have they not attached screen?
Roshan, what will be the course duration?
Okay, so the course duration will be the live. If you look at the entire the recorded session as well, it will be more than 60 70 hours. On the live sessions, we'll be taking up 35 hours to 40 hours. Yeah. So consider like a 2 month, okay, 2 months time.
Okay.
35 to 40 hours. Yeah. Then if they one more link, let me just check that. Okay, yes, Cloud P. Yeah. So let me. So both courses I have clubbed earlier. I have to take both the courses together. I have clubbed.
Roshan, you mentioned hands-on.
Yeah, everything is hands-on.
Roshan, hello. Roshan, you mentioned. So I was asking what type of hands-on is there in this course?
Everything is hands-on. So if I'm showing cloud, I'll be showing you all the services, how to provision, how to work. I'll be explaining all the things. I'll be showing you everything. When I'm explaining you containers, I'll be creating containers. I'll be creating Kubernetes cluster. I'll be deploying Jenkins. I'll be showing you pipeline. Everything is hands-on. I'm going to show you things how you do it. 90%, 85 to 90% is hands-on. You'll be, today I have spoken more. I'll be speaking, but I have not demonstrated, but mostly I'll be.
So is it?
Yeah. Go ahead.
Just a question. So are we able to do it? Because I just wanted to know, is there any charges? Let's say we also want to, experience how to create container resource and other things.
No charges.
So
I will let you know how to do hands-on without paying them. No charges.
Okay, yeah. Because my question was like, is there any free trial kind of thing and cloud or something?
Correct,
or
absolutely. Not? You are in the right direction, in the right way. All the cloud service provider has a free tier account. So we will be creating an account and we'll all be practicing. Yes, Raman, we'll be setting up.
Okay.
Yes, we'll be installing Prometheus. We'll be setting up. We'll be using Kubernetes. We'll be using Helm chart to install Prometheus, Grafana. We'll be using Docker Compose to install ELK. We'll be setting up all of those things. Yes, Raman. How many days you will share the videos? Daily, on daily basis. So let's say today evening, 9 p.m. to 10 p.m. I'm taking up the session. So next day morning, my team will be updating the video in your playlist. And it will be there with your lifetime access. Amia. Sounds good, Amia? Good. Anybody have any question? Feel free to ask, guys. And I was showing you the screenshots, right? Here is this. So all the people, I have shared this screenshot with the team. They have attached it here. All my learners. Okay. Yeah. So different batches, and you can go over the recorded sessions, guys. Okay. You will not be able to access this recording. Once you enroll, we'll be allowing you the access. Anyway, that will be your recording. So we'll be setting a new playlist, not the same playlist. A new playlist will be created for April month, right? Weekdays, April month, it will be created. We'll be taking up sessions and updating this on daily basis.
Roshan, Kishore here.
Yeah, Kishore.
Roshan, end of the course, will we be able to claim ourselves as an SRE engineer? I mean,
See,
provided. I mean,
okay, Kishore, understand one thing. I'm gonna expedite the process of you getting transition to SRE. Right? That's what I'm gonna. I'm gonna make your journey fast. SRE is a journey. It's a lot of things, right? I'll be showing you the path. I'll be doing the hands-on, which will help you 30 to 40%. But you will have to do practice, and you will have to join a company and work and implement this, right? So that's how any learning goes. If you join any Jmeter course, the trainer can teach you how to script Jmeter. But again, depends on the problem statement or your company application, whether there will be some other challenges, correct? Same thing goes here, right? So I'll be expediting, I'll be accelerating your transitioning to as being an SRE engineer. That's what I can promise you, right?
Okay.
You'll be start receiving calls. I'll be helping you with the resume updates. You need to work hard, right? Understand this. 40 hours of exhaustive training means multiply by 3, 120 hours of your hard time. Your working hard and practicing. That's what will take you far, right? That's how you should take it.
Got it. So the whatever syllabus you have mentioned in the course list, so would that be sufficient for me to run in the SRE path?
Absolutely. This is an exhaustive course, Kishore. Exhaustive course. You will never. I can claim you. I can claim. You will never find a course like this. It's totally customized course, whatever required for a performance engineer or looking for a career in the SRE and all the things. Look at this here. The even this 8 hours, 9 hours of recorded session. If you go over it, you will be a better performance engineer. Java performance engineer. Apart from all the knowledge that you're getting, it's bundled with monitoring, with all the cloud knowledge, Docker, Kubernetes knowledge, Jenkins knowledge. It's bundled. This course is bundled with Python programming, Java programming, self-scripting, Linux. Nothing can be beyond this, right? I would have loved to get, if I would have got this course maybe 6 years before my career. I have learned this hard way and sharing this. So, yeah.
Thanks, Roshan.
Sure. I'm getting some few questions. Venkat has a question. SRE will make sure application is under control by monitoring both functionality and non-functionality. Yes, SRE responsibility is to make sure production is highly available. Obviously, functionally also, right? See, functional breakdown mostly in production. See, functional behavior is first checked, then we do performance testing, right? Anyway, so functional behavior, if a page is clicking on logging button and the page you're not able to log in. That's a functional issue. Obviously, that's a concern in production. So yes, functionally, performance-wise, scalability-wise, in production, everything should be fine. Whatever happens in production is the scope of SRE. Yes, and proactively monitoring is the key. That's what I told about the alert that I have given you, the example, it's proactive alerting. How to create dashboard, Amia? See, dashboard creation, I will set up Grafana dashboard. I will talk about Prometheus Grafana. I will show you dashboard. I will take you some examples of dashboard. Dashboard creation is a performance engineers. You guys can do that dashboard creation, right? I will talk about Prometheus. I'll talk about Grafana. I will talk about ELK. That's what is more important, right? Dashboard creation. You need to know the metrics: CPU, memory, disk, response time, TPS, status code, errors in the logs. The dashboard's metrics remain the same, right? That's what you can explore that dashboard creation. I mean, but I'll be showing you Grafana dashboard. Yes. Okay, how long course will go? I've given the answer, Rahul. That will be 40 hours, 35 to 40 hours to 2 months. Consider 2 months of time. There will be always a 2 month gap, guys, between my two courses. Feb course is going on. I just showed you. Feb course is going on. You can see this 11th Feb it started, and right now it's going on. I'm and still with two more. That's a 2 hour course, 1.5 hours each. So 2 more sessions yet to go. Look at the time here, 16th April. So 11th May to 16th April. So 2 months. So consider 2 months for sure. Okay, so live you can see this example, right? So 2 months it takes. So do we set up a real-time SRE monitoring? Yes, this Raman, I answered you. Yeah. Is SRE jobs are shifting? SRE jobs are shifting jobs? See, that again depends on which role you are in. SRE could be a support engineer, L1 engineer, or could be a troubleshooting guy. If you would be troubleshooting the application, you would not be working in the shift, right? If you're troubleshooting application, it depends on your, see, SRE has got many roles and responsibility. Performance production monitoring, shift-wise is one of the job roles that SRE has, right? But if you're into troubleshooting part, development part, doing engineering part, you would not be working in the shift. It depends. I mean, production support is one of the roles of a, what I would say, the first role, production support, L1 engineer is, they also called SRE. But we are here to talk about mostly on the troubleshooting, guys. Okay, we are not talking about just monitoring production. We're not talking about just monitoring here, right? We're talking about a lot more things. I hope you are able to understand, right? We are we are talking from an architect point of view, right? Architecting solution, going to the root cause. And a production engineer, production support engineer would not think on all these lines. We are thinking from an architect point of view. Yes, able to understand where the course is going, guys. We are talking about so much in detail. Look at this. Kubernetes, we are detailed discussion. We are talking about performance engineering, right? Troubleshooting. Any last questions, everyone? Chris, this is very common question. There are 100 performance monitoring tool, Chris. Dynatrace. Then why did you skip Dynatrace, right? Splunk, Datadog. I cannot take up everything in the course. I have selected the open source, highly demanded monitoring tool, Prometheus, Grafana, and ELK. Come to the conclusion because I have gone over a lot of CVs, job descriptions. That's why I have come to these two tools. I can talk about Nagios also. I can talk about Dynatrace, AppDynamics. There are so many tools. New Relic. But we cannot take everything, right? If not, this course will be monitoring tool only. Okay. How many SRE jobs? Do one thing, guys. If you are having any concerns, right, go to your LinkedIn profile. I hope everyone has a LinkedIn profile. Go to your LinkedIn profile, go to the job section and search for SRE. Okay, just go to the job section and search for an SRE. Just search. Just search. SRE. Search. Just search. Okay, you're gonna amazed with the people that they need. Amazed. Big companies, small companies, everyone needs SRE engineers. There will be big team. It all depends on your company, what scale they're operating. If they have a big application, small application, how many people, how many production load they have, how many customers they have. It all depends on what would be the team size of the or SRE organization in a particular team. Able to understand, Venkat? Okay. So that's all I wanted to cover, guys, today. It was demo. We'll meet tomorrow again, same time. Okay. There will be a chance, guys, 9 p.m. I may have some calls. So just be in case, be ready to be ready. Just okay. I'll keep you posted in the group. Okay. But mostly we'll meet at 9 o'clock. If I would not be working professional, then it would be, I would not be making that statement, but it's a SRE role. You will understand production thing can come up. Right. So mostly we'll meet tomorrow at 9 o'clock. If not, we'll keep you posted on the schedule. Right. That's all, guys, from my end for today. Okay. Thank you, everyone.
Thank you, Roshan.
Sure. Thank you.